Hey there, everybody. We're going to go live in just a minute here. Get started talking about inverse functions. Get this going in just a couple of moments. May the 4th be with you today, of course. Nearing the end of the 2019-2020 school year. Only a couple more weeks to go. Trust everybody's doing all right during this interesting time. Of course, over here in Georgia, they've lifted the whole quarantine order that may or may not have been the right choice. That's debatable, but we're not necessarily locked down anymore. If someone's viewing this from that's not in one of my classes from another state or something, maybe you guys are still stuck at home. I got no plans to go anyplace anyway. Talk about inverse functions. All right, let's go ahead and do this. You're still stuck at home. Well, we're not. Personally, I still think it's probably the best idea to stay at home and away from people as much as possible. But I'm also kind of an introvert to begin with. So this really hasn't been a huge issue. Although I do kind of miss going to work and seeing you guys. All right, well, let's go ahead and get going here. There we go. So, inverse functions. All right. The whole idea here is that you're going to swap the input and the output of your function. In other words, you're going to swap the x and the y values. Okay, that is really all there is to it conceptually. So if you're looking at like ordered pairs, 3, 7, that's going to become 7, 3. All right, here we've got an x value of -5 and a y value of +2. So you just swap them. 2, -5. 2 becomes the input. -5 becomes the output. If you do remember from geometry, like a year ago, okay, this was a reflection over the line y equals x. Okay, and if you think of it similar to that, that was where the rule was x comma y became y comma x. So that is, in a nutshell, everything that's going on there. All right, so if you have a table, mapping, a graph, ordered pairs, function notation, however, if you're only being asked to state the new thing, all you got to do is swap the swap the x and y. Flashbacks from geometry's not that bad. Okay. Pardon the bark in the back. So algebraically, take it out of function notation if you need to. If it's not already in function notation, you don't have to worry about this step. All the ones that we're going to do down below are in function notation, so we are going to have to take that step. Then, just like we were saying above, swap the x and y, and then you solve for y. And then finally, you put it back into function notation. All right, so let's do one. Scrolling down here. Number 9. It is in function notation because there's an f of x here. F of x or g of x or however it's done is synonymous with y. So we'll go ahead and just change that into a y. So now we have y equals 2x minus 3. And the next step is to swap your x and your y. So now it's going to be x equals 2y minus 3. And all you have to do now is just solve for y. Okay, this is really just practicing some of those Algebra 1 type skills. We'll add 3 to both sides of the equation. X plus 3 equals 2y. And then divide both sides by 2. Okay, so we've got x plus 3 over 2 equals y. And then we'll change it back into function notation. The y goes back to being an f of x, but we're going to put a little -1 looking exponent up here. That indicates that this is the inverse of f. And that's going to be it's going to be x plus 3 over 2. Okay. In most cases, that's going to be an acceptable final answer. You might find yourself where you need to take the 2 and apply it separately to those. It kind of depends on what format you're being asked for. If you do need to do it that way, just x over 2 and 3 over 2. So that's basically the same thing. Why does it change into f of x? Well, because we started with f of x. So it becomes the inverse of f of x. The next one we'll do g of x and the inverse of g of x. All right. I am going to stick with this as the answer, though, because it's just plain simpler than anything else that we did down below. And then we need to verify. Okay. To verify, what you're going to do is take the original 2x minus 3, and in the place where the x was, you're going to put a nice big empty set of parentheses. And then inside those parentheses, you're going to place what we believe to be the inverse. 2 times now x plus 3 over 2 minus 3. If when we simplify this, we get just x, then we know we did it right. Okay. Now, since you're multiplying this, if you want to think of this as 2 over 1, you can. Point being that the 2 on the bottom and the 2 on the top cancel out. You've got x plus 3 minus 3. And 3 minus 3 is 0. So you're just left with x. So it definitely checks out. We verified it. And that is essentially it. The other examples that I've got here, the only difference with these is that middle bit, the algebraic part of how we go about solving for y. We're still going to start the same way. It's g of x this time, but that becomes y equals x squared plus 8. Swap your x and y, so we are looking at x equals y squared plus 8. And then solve for y. So we'll subtract 8 from both sides of the equal sign. That's going to give us x minus 8 equals y squared. And then we need to get rid of this square to use the inverse operation, which is to square root it. Okay, remember that anytime you are the person who introduces a square root into the problem, you do need to consider both the positive and negative square roots. So it is going to be plus minus square root of x minus 8. Okay, now the last thing is to turn it back into function notation. So the y is going to become the g of x format again, but since it is the inverse, we are going to say g raised up to that negative 1 power of x equals the positive and negative square roots of x minus 8. So that's what we believe the answer to be. In order to be totally certain, we're going to need to verify it, okay? So just like before, we're going to write this down, the original, but instead of an x, we'll put a nice big empty happy set of parentheses. And then inside those parentheses, we will put what we believe to be the inverse, positive negative square root of x minus 8. Okay. Well, now that we've got this in here, really the plus minus isn't making that much of a difference. The whole reason we did that, all right, and this is just as an aside that you don't really need to know per se in this context, but if we were graphing, the original would have been a parabola looking something like this, and the new version would be a sideways parabola looking something like this. Now, if we didn't put the plus minus in front, you'd only be looking at this piece, okay, which means you're not looking at an actual inverse. Okay, so that's what the plus minus does. The point there that I was trying to make, though, is when you cancel out the root and the power, the plus minus is going to go away as well. So you're really just looking at x minus 8 plus 8. How do you do the inverse? Can you give me more detail on that? Like graph or what we've been doing, or what are you looking for there? I mean, finding the inverse is all this stuff here. So step 1, we took it out of function notation. So g of x became y. Then we swapped x and y, like we did here. And then everything else there is just solving for y. So all of these steps here are your basic algebraic manipulation, opposite operations. So plus 8, we did minus 8. Instead of squared, we did square root. all that good stuff. And then the last part was to put it back into function notation, which is where that whole G inverse x comes from. Now, everything that we did down below, this is verifying it, okay? Because that's another part of doing the inverse, is you can sometimes be asked to verify it. And the way you do that is to plug the inverse that you found into the original. Okay. Technically, you're supposed to do both. Plug the original into the inverse as well, but I'm not going to really stress over that. All right, let's do a couple more of these. This time it's h of x. Sounds like some part of the Russian Revolution. The h of x. We're going to change that to a y. Let me go back to a easier to see color. There we go. Y equals 2 cubed root of x minus 1. Oh, that should be an equal sign. And then you swap the x and the y. So now we've got x equals 2 times the cubed root of y minus 1. And from here, we're going to solve for y again. So the first thing we need to do is move this 2. Okay, we can't do anything with whatever's in here because it's underneath this radical. What we can do, though, is divide both sides by 2. That's going to give us x over 2 equals the cubed root of y minus 1. The opposite of a cubed root is a cubed power. So we are going to raise both sides of this equation to the third power. This is being applied to both of those guys, so we are going to incorporate some parentheses here. But you've got x over 2 to the third power now equals y minus 1. And then only one more step to get the y by itself. We'll just add 1 to both sides. Okay, so what you're looking at is x over 2 being cubed, adding 1 to that, and that equals your y. Okay, the y, we're going to put it back into function notation. This is going to be h, but it's the inverse of h of x, and that's going to be, well, what we just wrote down a second ago, x over 2 to the third power plus 1. Okay. So that's finding the inverse. Now we need to verify the inverse. So I'm going to take the original, alrighty, and in the original I'm going to replace the x value with a nice big empty set of parentheses. Okay? And inside those parentheses, we're going to put what we just found to be what we believe is the inverse. Okay. This one does look a little bit weird when we're verifying it. These parentheses, the blue ones, they're not really doing anything on the inside there. So we can just drop them. And we end up with 2 times the cubed root of x over 2 cubed plus 1 minus 1. And the ones cancel. So what we've got now is 2 times the cubed root of x over 2 cubed. This time, though, well, this is where the root and the power, since they are opposites of each other, they're the reverse of each other, are going to cancel each other out. So the radical goes away. I am going to leave these parentheses alone to have x over 2, which is now being multiplied by 2. The 2's cancel out, and you're left with x. So it checks out. All right. Looking at that one for verifying, got a little bit more interesting. Let's see what happens with this one. We're doing m of x. Again, start by changing it from function notation to just standard xy notation. And then swap the x and the y. And then here we're going to solve for y. So we'll start by multiplying both sides of the equation by 2 so that those can cancel. So on the left side we have 2x. Subtract 4. We've got 2x minus 4 equals 3y. And then divide by 3. So it looks like 2x minus 4 over 3 is our value for y, or expression rather. All right, and then just change it back into function notation. The y now becomes the inverse of m of x, which we believe to be 2x minus 4 over 3. Only way to be certain is to verify it. So I'm going to come down here. I'm going to take the original, which is 3x what was it? Plus 4 over 2. Plus 4 over 2. And then inside the parentheses, we will place what we believe to be the inverse, 2x minus 4 over 3. Cool? Okay. All right, simplify. This is a 3 over 1 up here in the numerator, so we can do the 3 and the over 3 canceling out. So the top is now just 2x minus 4 plus 4 over 2. Negative 4 and positive 4, they cancel out. So we have 2x over 2. The 2's cancel, and we're left with x, which is exactly what we wanted to see. So we found the inverse. It is 2x minus 4 over 3. All right, just 2 more of these, and then we'll be all set. We're going to do J and P. Okay. I tried to make a couple of examples that had a little bit of difference behind how to solve for y during that step. Everything else is basically the same. All right, J of x becomes y. And you swap the x and the y. And now everything we're going to do is just to isolate the y, get it by itself. So add 7. We have x plus 7 equals 3 times that guy squared. The 3's on the outside of the parentheses, so we're going to take care of that next. Divide by 3. We have x plus 7 over 3 equals y plus 4 squared. To get rid of that squared, we're going to use the opposite. That's a square root. Anytime you introduce a square root, you do need to consider both the positive and negative roots. X plus 7 over 3 equals y plus 4. And then subtract 4. So we've got positive, negative, square root, x plus 7 over 3 minus 4 on the outside equals y. Back into function notation, this is going to be the inverse of j of x equals all this stuff that we just wrote down. Plus minus, square root, x plus 7 over 3 minus 4. Okay. Some of these answers are starting to look a little crazy, but hopefully the process of getting to them is not losing you. So to verify, we're going to need to do 3 times. Now this is a parenthesis that's already in there. For the x, I am going to go ahead and put another parenthesis in. We're going to drop it in a minute anyway, but just for consistency. Plus 4 squared minus 7. Inside the parentheses, plus minus square root x plus 7 over 3 minus 4. All right, there's a lot going on. Like I said a second ago, these inner parentheses, they're not actually doing anything for us, so I'm just going to get rid of them. Plus minus square root x plus 7 over 3 minus 4 plus 4 squared minus 7. All right, here we go. The negative 4 and the positive 4, they are going to cancel each other out. So we have 3 equals the positive negative square root of x plus 7 over 3, which is squared, minus 7. Okay, at this point, the square root and the squared are going to be what cancel each other out. So we now have 3 times x plus 7 over 3 minus 7. Okay, now the 3's are going to cancel out. So we have just x plus 7 minus 7, which is, once again, just x. So we've confirmed that the inverse of j of x, positive negative square root of x plus 7 over 3, and then the whole thing minus 4. And like I said a second ago, while these are starting to look kind of crazy, hopefully the process isn't getting lost on you. Having something like this is probably going to be, for an Algebra 2, very, very, very rare, if ever. More than likely, you'll end up with things that look kind of like these first two, or, well, this one here, and then, well, really just this one here. For the most part, they're going to be linear. Not often will higher exponents be involved. All right, one more. Let's finish this up. Y equals 2x squared minus 5 over 3. Swap your x and y. X equals 2y squared minus 5 over 3. And solve for y. Multiply both sides by 3. We're looking at 3x equals 2y squared minus 5. Add 5 to both sides of the equation. You're looking at now 3x plus 5 equals 2y squared. And divide by 2. So looking at is going to be 3x plus 5 over 2 equals y squared. All right, as usual, opposite operation. We're going to square root both sides. Again, since we are introducing the square root ourselves, we do need to call it a plus minus square root of 3x plus 5 over 2. And that is going to equal y. So back in function notation, that'll be the inverse of p of x equals the positive and negative square root of 3x plus 5. How did I get 3x? Well, 3 times x right here. Since there's a 3 down below and we need to cancel that out, we multiplied by 3, and then that gave us the 3x. Okay. Only one thing left is to verify that this is actually the inverse. So let me go back so I can see what that is. 2x squared, 2x squared, what was it, minus 5 over 3? Yeah, minus 5 over 3. And then inside the parentheses, we will put what we believe to be the inverse. Positive, negative, square root, 3x plus 5 over 2. Cool. All right. The square and the square root cancel each other out. That gives us 2 times 3x plus 5 over 2 minus 5 over 3. The 2's will cancel out. So now we have 3x plus 5 minus 5 over 3. Plus 5 minus 5, they cancel out. We've got 3x over 3. And the 3's cancel out. And we're left with just x. So there you go. We verified that that is also the inverse. Okay, so like I said a couple of times, the crazier ones like this one, if you see something like that as you're working, it'll be kind of a one-off. It won't happen frequently, if at all. For the most part, they'll be linear, like the first couple of examples we did. And that's basically it for finding the inverses. Any extra question I could answer about it or help I can give? All right. Well, then I will catch you later.